the Dales, or Yorkshire Dales. And here you see Sam Murphy by the side of a bale, and this is one of the best ways to find bales. If we're just driving over the road from Ascrig to Buca, and we said, oh, that looks like a bale there. Well, at the second stop, we stopped at this, and it actually was one. And this, we identified it as a bale because right in the middle of nowhere there are very small, tiny prills of lead, loads of them. So somebody's been smelting lead ore there, and that's what you see. We couldn't see any slag or any other residues, but loads and loads of prills of lead. So we're going to start with the sort of perceived knowledge of lead smelting when we started this project. It's a technology known to have been used from about AD to 1200 to 1570, when bales were superseded by the ore hearth furnace. I'll come on to talk in more detail about what they were, but basically they're just open fires, they're bonfires, and they just heap lead ore onto them and get molten lead out of the bottom. And that technology was used in the Dales from, well before 1200 now, that we found out, up to about 1570 when the new technology came in. And the spread of technology at that time seems to be quite fast. It seems to have been introduced in the Dales. 1590, there are maps with the new mill at Marrick is shown on it. And it's the ore hearth technology for smelting lead seems to have come in very, very quickly. They were open fires, and they used to smelt galena lead ore. This, again, the perceived knowledge is that they were situated on the exposed edges of hills, facing the prevailing wind, so you could get a good draft. And we since found out that there are quite a few aren't in those positions. They're in neutral or sheltered locations, and they may even be furnaces, not open fires. So that is something that we found out, and I'll come on to deal with that in detail. Not that there are many sheltered locations anywhere in Swaledale, or the Dales for that matter, when there's a wind blowing. Again, it was said that they were wood fires, sometimes enclosed within a circle of stones, or sometimes built against a wall. Well, we found little evidence of structures, but some evidence that some of the later sites, or what appear to be later sites, used charcoal in some way, which I'll come on to discuss again. The reason we haven't found any structures is, of course, any self-respecting lead smelter, as soon as he's finished with his smelt, will destroy any structure to get the remains of the lead out. So the smelters will have destroyed them, and that's unfortunately the position we're in. And some of this, there is a secondary process where the slag, which contains lots of lead, is resmelted in what is known as a blackwork oven. And that knowledge is based on documentary evidence, but the archaeology of medieval furnaces in general wasn't very well understood, and it's not very well understood now after 20 years looking at it. Lawrence Barker, who some of you may know, who lived in Helaw, did some pioneering work in about 1978. He identified about 30 or 40 bale sites in Wensleydale and in Swaledale. You see them here, the red and black spots. And Sam and I then went around in the first year, 2002, when we could get on the land, trying to find these. Unfortunately, Lawrence's map references were only 3-figure map references. So we actually found a lot more bale sites just looking for some of the ones that Lawrence had reported. But you'll see that many of them are on very, very high ground, facing the prevailing wind. But some, not all of them. There's a couple up here which are off the map, and of course there are some in Nidderdale and Wharfdale as well. So how do you find lead bales? One way is looking at place names. It's thought that bale is a Norwegian word, Viking word, meaning a fire. And so you find very often names like Bale Ing, Bale Bank. The place names are the blue squares with a white centre. And the places where we've actually found some smelting residues are the blue squares with a yellow centre. The first thing that strikes you with this, by the way, the villages mentioned in Doomsday have got yellow squares around them. First thing you notice from this is that the lead mines over here tend to be in the west, and that the smelting is carried out in further towards the east. Probably two good reasons for that. In Nidderdale, certainly in the early medieval period, around 1300s and before that, the mining was all carried out by the monasteries, Byland Abbey and Fountains Abbey. Byland tended to mine half of this area here, and the other half of that and the rest was mined by Fountains. Byland tended to take its ore off towards Kirby Malzard, which I think is somewhere up here, and Fountains is over here on the right in the east. So these sites here, there, if you draw a line more or less between where the mines are, where the river crossings are, there's a bridge, there's a bridge at Summerbridge in before the 16th century, and there's this crossing here which is a ford called Ledwath. You find that they're very often on tracks leading towards Fountains Abbey, and you can tie many of these in with nearby granges, and some of the footpaths can be traced that connect both the Fountains Granges and go very, very close to some of these working sites. The thing about this smelting of lead ore with wood is that carrying the lead ore isn't a big problem. There's not much difference between carrying the lead and carrying the lead ore. There's not much difference in weight. It's obviously there's a little less lead, but not very much. The big problem is carrying the wood. It's not very easy to carry. There's lots of it, and you use roughly about 5 times the weight of wood to the amount of lead ore. So you find that these sites here are on the way to woodland. They tend to, certainly in Swaledale, they tend to be on the way to woodland and not on pasture land, because it was known from quite an early time that pollution did occur and you couldn't raise animal livestock on land that had been bellanded, as it was called, by smelting lead. A number of problems with doing this work in Nidderdale is that, unlike Swaledale, a lot of the land around here is enclosed, so you've got to get permission for people to tramp on the land and look at things. It's also very fertile, so these sites tend to get grassed over very easily. And the mineralogy of the ores is different. There doesn't seem to be very much silica in the Nidderdale slags, in the Nidderdale ores. So there are very few slags. The non-metallic components that you find in Nidderdale are things like fluorspar and calcite, and the calcite just burns as you would burn limestone in a lime kiln. It forms quicklime, and then of course a bit of rain and it just disappears. So there are it's difficult to find it's very difficult to find traces of smelting in Nidderdale for those reasons. But in Swaledale and Wensleydale, much easier, much more exposed, and you can go around and pick out these signs by great spreads of stones and blackened areas and that sort of thing. Another way of finding bale sites is sometimes you're lucky enough to actually come across documentary evidence. This is a map of Marwick Priory, done after the dissolution, and probably because somebody wanted to map the land that he just bought. And there's Marwick Abbey down there. There's the Copperthwaite vein up here, which is a huge vein. And two sets of bales. One is called just 4 bales in a line, which is an area that you can identify nowadays. Bales have been there. And this one here, which, back again, right, is not quite sure whether this is the prioress's bale, because it was an abbey that had nuns in it, or whether it's the priory's bale, but it probably isn't the prior's bale. Anyway, this is the area, this is the one where the nuns of Marwick Abbey smelted their ore. And when you go there on the site, you just see this hill on a flat plain. It's above Fremington Edge is all this, well above Fremington Edge. And there is this raised hill there in the middle of it. And the areas of interest are these two places here. One of them, the one to the right there, may be a structure, but we didn't find any lead smelting residues there. And then the other one, where we found two things. We found the stones have been glazed with this transparent green glaze, which basically is lead silicate, and splashes of yellow lead silicate on the stones, and quite a few of those. Now, that more or less identifies the bale site. We would identify a bale site as, you've got to be careful, it's really got to have evidence of lead smelting. So molten lead, lead prills, something like that will be evidence. This type of unequivocal lead containing slags is other evidence. Bits of galena, lead ore, is not evidence, although it's supporting evidence, for the simple reason that it could have fallen off a pack horse, or it could have been near a mine. And the other things that you find out very often are reddened stones, made red sandstone by heating. And again, that's not really evidence either. We would need more evidence before we call it a proper bale site. This is a map of 1718 in the Record Office at Northallerton, and it's above Langthwaite. Langthwaite's down here somewhere. There's Garthdale Beck running up here, and that's the road to Booth there. And we've got this field here called Bale Intake. It's changed its name at least twice since then. Or maybe had 2 or 3 different names since then, according to the farmer who owned it at the time we looked at it. So Bale Intake is another named site. And that just, again, looks rather like the Prior's Bale. But strangely, the smelting areas here, and so forth, are not where you would expect them to be. They're not on the top of the hill. We found charcoal, some on the top of the hill there, and quite a spread of it, and another spread over here where there was no smelting taking place. We got that carbon dated, and it really disappointed us because it came out at about 1670. which was 100 years after it had all happened, when they finished bale smelting. It's quite possible that it could be anachronistic bale smelting, that somebody had still kept the technology going, or it could well be that it was nothing to do with smelting, it wasn't the charcoal. It may have been stuff that had been kept for a beacon or something like that. Which brings me back to the Bale place names. We looked at Bale place names in the North Pennines, and some of the Bale place names there are very unlikely for a Bale site. They're right on top of peaked hills called pikes, and it's probably the Bale in those cases were actually warning fires. They were beacons to indicate, you know, the Scots were coming or something like that. So cross-section of the hill from more or less where I'm sitting here, is it goes up like this. This is the flat area that you can see on the photograph there. The bales are at the bottom of this hill, and there's a charcoal remains were found up there. Not a great deal, but some, and it wasn't particularly thick charcoal either. What did we see? Well, there's me looking at one of the sites, and you can see that we found pieces of lead and slag on stone here. So they're quite obviously they were used for smelting. Another thing that you might see is this is at Telfit Bank. It overlooks Clints near Marsk in the east of the mining field, and there's a big pollution scar on this northeastern facing slope. There is absolutely no smelting debris or anything like that in there. It's a pollution scar, but note that wall there, because on the next slide, that's the wall. And on the crest of this rise, you'll find the smelting sites. And one of the puzzling things we find with many of these is that there are these pits. And we haven't really worked out why there are pits at many of the sites, not just this one, and what they were there for. It's possible that smelting was actually carried out there and people have dug holes to get the last of the lead out. My own company had a smelting works in Bedminster in Bristol. When they took the blast furnaces down, they found tin and lead 15 feet below the furnace. So it's very penetrative, is hot metal. And so that might be one of the reasons. The other reason that these may have been pits used to remelt the lead from the fires, because it wouldn't have come out in any sort of recognizable way. It would just be a mess, and they'd have to collect it up as well they could and remelt them in small pits at the side. So that might have been another reason. Just over the wall, the wall obviously postdates the smelting. It's difficult to say if that actually carries on the other side of the wall, but there is a circle of stones which looks as if it's been the site of a hut or something like that, probably a workman's hut. The other way to find out a bale site is have a rebellious wife. We've left the car at the road from Grinton over to Redmire, and we walked all the way around Brownagill, and we were intending to go back. And so it got to about 1:30, and she said, "I'm fed up, I want to sit down and have my lunch." And she sat down on the bale site, and she's done that before. So, you know, you've heard of sniffer dogs used for various reasons by the police. This is my sniffer dog used for finding bale sites. So, chemistry lesson. Lead is found as a galena. This is a nice piece of it, and you'll see it's got the lead ore here, nice and shiny, but it's also got other metals, other non-metallic components like calcite, barytes, and that sort of thing adhering to it. The process of dressing the lead ore is to smash it all up and try and get as much of this off as possible. Lead ore is heavy, so you can float some of this off, or use various gravity techniques to get rid of it. But a piece like this is probably as good as you're going to get. So that then forms a slag, and that is a key to finding these sites, or certainly a key to finding about the chemistry of what's been going on. They say in smelting that don't bother about the metal, that'll look after itself. Get the slag right. And the slag is the thing that gives you all the information about what has gone on. What happens here is that lead is there as lead sulfide. If you put that into a blast furnace, for example, all you get is the same stuff coming out at the bottom as a black mess. You first of all got to burn off the sulfur. So and this is where the bale comes in particularly handy. You can imagine a bonfire, there's plenty of air there getting into the fire. This reaction takes place at about 600 degrees centigrade, so it doesn't need a lot of heat to get it going. And sometimes it's a partial oxidation, you get lead sulfate formed. The lead oxide then that you've produced in this reaction reacts with carbon monoxide, usually further down in the fire from the charcoal that the wood is formed, and forms lead and carbon dioxide. Lead sulfate is reduced by carbon dioxide, and you get that again. So those are the key reactions. There is another reaction where if you can get the fire hot enough so one of these components, such as lead oxide, melts, about 900, it will react with more lead sulfide, and you get a liquid solid reaction, and lead is produced again. So that's the end of the chemistry, you'll be relieved to know. The other one is a ore called cerussite, which isn't really important in the Dales, but it's lead carbonate. It's formed by the oxidation of this due to weathering over geological time. But in the Lake District and North Pennines and the Colbeck Fells, just north of Skiddaw, there's quite a bit of cerussite. And the miners, even in the 1800s, start of the 19th century, were throwing this away. They couldn't tell the difference between this and some of the crystalline materials that were in the lead ore, and they just threw it away. It's very easy to smelt and gives good lead. So what do we know from historical documents? Well, this is Agricola's De Re Metallica, and he's got a German bale furnace here, which is a pile of stones, and it's both of these furnaces are raised stone beds, rather like an altar. In this case, Q is charcoal, so they were using charcoal, not the wood, to smelt the lead ore there. But you can see that on the surface there's plenty of exposure to air. You can oxidize the galena that way, and then further down in the fire it gets into the red hot charcoal and produces this mess of lead that's coming out here. A Polish hearth does more or less the same thing, but in that case the straw there, why they must be using straw to help the initial oxidation, but somehow they'll have to get carbon there, and this again forms lead on the floor, making really what is a mess. And so they have to melt it up quite separately in this dipping pot here. Arthur Ray Strick, who you all have heard of, surveyed, this is about the only piece of archaeology that's known of bale smelting in Yorkshire, this site at Winterings, where he found this stone circle, which he reconstructed to be, obviously it was going to be something like this. And so for best part of half a century, the Yorkshire bale site is encapsulated by these pair of drawings. Sam and I were able to find at Bradford University some of Raystrick's old notes, and there was a map reference to where he'd found this site. We went and had a look, couldn't find it, but in fairness to Raystrick, his work was done in 1912 and published in 1917. We were trying to do this sometime around 1990. So we didn't find it, and the area had been heavily grassed over. It was in a sheltered spot, not an exposed spot, as the perceived knowledge tells us. And what we did find was a piece of lead that weighed 2 kilograms, right in the middle of nowhere there. So another type of bale that is documented is, if you can imagine, 2 side walls with a wall at the back. So forming, this is a cross section, that's the back wall, and the side walls will be here. This is a type that was used in Derbyshire, and the reason we know it looked like this is because there's a detailed description. Around 1570, 2 new furnaces have been patented, and the patents were challenged in court. And so they went through all the thing of how did you smelt bale, how did you smelt lead traditionally in the court, and this was part of the court proceedings. Basically, this thing was quite a huge thing. They kept them going for about 5 days, smelting the thing for 5 days. They produced an ingot of lead which weighed 2 tons. Don't ask me how they lifted that and carried it. It must have been strong guys, but it was part of lead smelting is you make the ingots as heavy as possible so people don't pinch them. And Roman ingots are about 160 pounds or so in weight. And that seems to have, that 160 pounds seems to have been preserved right the way through to the 19th century. People seem to have got that. It's about as heavy as 2 blokes can lift. Very difficult to nick off with. Now, this particular type of bale, there were wood tree trunks to form the foundation, covered with slag, and then smaller tree trunks called shankards put here. And it's likely that these just acted as a filter. They didn't burn. The burning stuff was branch wood and lead ore, which was held above them. You'll find that in wills at Derbyshire, these things were actually passed on from father to son, because there's quite a lot of lead still left in them when they'd finished smelting. One at Totley has been excavated, and here it is. And people I've spoken to observed the excavation think there was quite a lot of imagination went into that drawing, as well as archaeology. Winterings, you find these puzzling things here. There's smelting debris up here, a huge pit here, probably about 3 meters across. What it was, we don't know. Was it a fire that somebody has excavated out to get the last of the lead out? Or was it just the foundation of a hut? You know, it's a pretty exposed spot up here, and the workmen who were up there would have wanted somewhere to put their tools and keep dry. Another one, this is Alan Powell and my wife, doing a resistivity survey of a site at Spout Gill, where there may be maybe a structure there, or we don't know. We never found anything. We did a resistivity survey and a flux gate gradiometry survey, and neither of them showed very much. Fell End, another thing here where there may be a structure there, we don't know. Lots of debris, and it had fallen down the hill, and there's a pretty steep drop there. You can walk up and down it, but it's steep. And at Spout Gill on a lower site, we found this. I wouldn't worry too much about the circle of stones there, but within that circle, there are lots and lots of lead prills, and you can see they don't extend very far outside it. So again, point of interest, what's been going on there. We looked in detail at Carver Hill, which overlooks Reeth and Helaw, and we've been there back many times. We went there originally because this is where Lawrence Barker had found most of his bales, and we found a lot more. And we found it became apparent to us that there were three different kinds of bale. They're the ones circled in yellow, the ones in red, and the ones in black. The yellow ones tend to be near mines. These are mine shafts or mine workings, very shallow. There's some there, and the main workings are on the top here, and the bale, there's a bale there, there's a bale there which is difficult to find, and then this one here which is quite easy to find. There's another one here which has been cut across by a quarry. There's a remains of a lime kiln there, and again the remains of what looks like shallow mine workings. None of the mine workings are recorded in the record office or anything like that, and obviously not very much has come out of them. The slags that you find there are these that we saw earlier and before. They're splashes of lead silicate stuck to stone. Lead silicate melts at 760 degrees centigrade, so it doesn't require a great fire to actually make lead and produce this sort of slag. These are completely different. These are big sites. They're scattered over quite a large area. Sorry, the red circled ones, there, and there, and they're scattered over quite a large area. These are particularly big. And they have these slags here, which really are unchanged, barium sulfate. I'll go into those in a bit more detail later, which is varieties held together by lumps of lead or lead oxide. Loads of lead in them, probably about 30%. So, and then finally, we've got two huge sites down here, and there's absolutely acres and acres of slag, as is indicated by the red markings here in the area. And both of these sites have charcoal dumps near them, and they have black slags. And the black slags look on the surface the same as the previous kind of grey slag. When you break them open, they're either shiny black or they're dull black, and they have no lead in them. So we proposed, and it seems to hold up, there's the suggestion that there are three different timelines here. We've got early lead smelting, were probably carried out by the miners. They probably took the wood up with them every day when they went to work. When they got enough lead ore, they smelted it next to the mine. Appears to be what's happened. They weren't very good at the technology of making the fire to get it hot enough. And these were the sites where they produce lead with a not very hot fire. The slags melt at 760 or so. You've then got a change in what is happening, and the ore is obviously less well dressed because there's more non-metals in the slag and you get this more industrialized type of slag, of smelting going on. And you'll notice it's lower down the hill. It's still on an exposed position, but it's further down the hill and more remote from the mine. And then finally, these huge sites here, which are both dated in the 1400s then, look where there has been a real industry going on here. These slags with about 30% of lead in them have been brought in, and maybe from smelting areas further afield, nearer the mines, the big mines, up here at Old Gang and Surrender and the like. And you've got some form of industrial process taking place. Now, we know from looking at Swaledale wills that by the 1550s or so, about the time of the dissolution of the monasteries, there were people, there were distinct classes and division of labour taking place in the Dale at that time. There were people who were mining, there were people who seemed to be miners, smelters, and we could tell that they were smelters because they were owed lead ore by other people when they died. So the debts are there in their wills, but then they have debts in terms of finished lead. They had obligations to supply people, sometimes in York, finished lead, and these appear to be middlemen and could have well have been in the position where they were carrying out or masterminding the smelting. So just looking at the archaeology here leads us to at least come up with this hypothesis of how things have changed over the centuries. This is one of these reworking sites. There's Lawrence Barker there and Sam up. We basically, you can see, mapped out where the bare areas were. These are these areas that you see here. They're bare, they're absolutely covered in slag. I really don't know, why they've spread the slag out over such a large area. And then at the top of the hill, we find an enormous charcoal dump. Most of that area that you see covered in bracken, the vegetation is completely different. It's bracken, it's marshy, whereas down here, it's dry area, bit of heather, and that is one great lump of charcoal. It looks as if they've been bringing in charcoal to do high temperature smelting of slags that other people had made. We've got sites here, we've called them bales, but they're just sites where we found slag. And there may well be sites where slag has been brought in from other sources, and it's just been dumped there in preparation for it being smelted in this area around here. And these pits seem to be where the business was carried out. So we got the slags, and at home I've got an oven that will go to 1200 degrees centigrade, which is quite handy. So we put them on, I put them on tiles and measured the melting points, which sounds very easy, but it's not, and you burn yourself. And measured 3 melting points. One is felt it with a long stick with a 2mm bent rod on the end, so it didn't take too much heat out of the system. And every 20 degrees or so poked at the slags, and the first temperature I recorded was the temperature at which they started to soften. The second temperature was the temperature which I could poke the poker through to the bottom, and then the third temperature was the temperature which it seemed to run and become completely molten. You see, some of these never became completely molten. And plotted the results here, and you see some of those yellow slags melting about 760, very short melting range. Others, although they start to melt at a low temperature, it takes quite a bit of cooking to actually get them to go, and through on you get this sort of range. So what about historical documentation? Well, the Yorkshire record isn't very good. There's plenty in the monastic record about supplying lead, particularly from Fountains Abbey. Some of it was used on the roof of the abbey at Clairvaux, and other religious establishments. But this account of the bishops of Durham covered a period of about 100 years between, will that be Henry VI when he was allowed, and Henry VIII. And there are about 11 big documents in this collection. And two of them, one of them is an account by the man in London who sold the lead, and what he got for it, how he sold it. Another one was the same guy who was buying goodies for the Bishop of Durham at the time, jewelry and stuff for his female acquaintances and the like. And the rest of it is an in-detailed account of the mines, where the mines were, how the lead ore was brought to collection points, and how it was smelted. And that for us has been basically a gold mine of information. It wasn't easy, because it takes you about half an hour to actually get my eye in on this, but it is very well written. But it's in Latin. And apart from one of the accounts, they're all in Latin, except they're not in Latin. A Latin dictionary won't help you very much. A lot of the technical terms are anglicized. Some of them are in French. And many of the words that we couldn't work out, we actually found in an Anglo-Norman dictionary that was online. What does it say? Well, up here, et salute, and there's the translation there, et salute Robert de Wheelhouse, bowler, Robert the Wheelhouse, a bowler, pro combustion. You see, some of it's is abbreviated like this, which makes it very difficult. Combustione et fonera, I think that is 8 fothers about a ton of lead, and 166 petra stones of lead in bowling, by bowling this year. And then it goes on to say how they paid John Denning some money for doing the same sort of thing. So they're paying Robert de Wheelhouse here for bowling. And it goes on to say each fother of lead weighs 180 stones, and a stone contains 14-pound troy. And they received for each fother, the smelter received for each fother he smelted 5 shillings. This term exponentiae FCA, if anybody would like to tell us what that means, I'd be most grateful. But it looks as if it's free of other expenses. So he was paid for 5 shillings a fother for the lead, but that didn't cover the cost of the wood, and that was found by the bishop's agent. And finally, they were paying out for felling, chopping, carrying wood, fuel, and materials necessary for making this the same, and that cost £4, 12 shillings. This is the same piece of paper, same piece of vellum. Further down, and to pay the said Robert for burning, melting, and casting 3 fothers and so many stones of lead by smelting. So the first few lines, you were paid for bowling the lead, and this immediately below is for smelting the lead this year with a wheel. Each fother of the weight stated, you see there, and he's got the exponentiae FCA there. So he's paid 12 shillings a fother, and finally for making charcoal and carrying the same. So he's got two processes going on here. He's got bowling, and he's paying for the wood for that. And he's got smelting with a wheel, which we've taken to be, there's a bit more to come on this. Whoops. Again, each fother of lead, a stone, £14, but sorry, that's the first one. And to the same Robert for burning, melting and casting 9 fothers and so many stones of lead with a wheel and by the feet of men. Cum pedibus homine, it said. And what's happening, because there's another account where they describe why they use the feet of men. They say that they're obviously smelting with the bellows. They refer to treating of the black work here, so that the black work is the slag. And in the other account, it said they had a period of drought when they had to smelt with the feet of men. So here they're using a water wheel to drive bellows. And as far as we know, it's in a field or in a very rudimentary shelter to keep the rain off, and nothing more than that. And then when the water supply dries up, they have to use the feet of men. And there's two ways they can do that. One is the men can get in the water wheel and use it like a treadmill, which is probably what they did because it would be the easiest way to do it. And again, other accounts, the smelters were paid 4p for some of the work they did, but the guys who did the treadmill work were only paid 3p a day. And the foot blast here, which we have on the publicity notice for this meeting, shows the old order. This is the patent dispute, and these were produced in court. And this shows a foot blast blowing a furnace, and it's the old technology. And here we see the feet of men used to drive the foot blast. 2 furnaces were developed then. There was the German or Almain furnace, which basically didn't work because you can see this is a blast furnace. The Germans used it for copper and it worked, but it wouldn't work very particularly well for lead because there's no way you could get air into the lead to burn it, the first stage that you need to burn off that sulfide. And that's what the Orhar furnace did here. It's like rather like a blacksmith's furnace. The lead ore oxidizes on top, trickles down, and then you get molten lead coming out once the lead oxide has met the coke or the fuel or whatever it is. The slags, the black slags, just you get them shiny, or some of them are dull, and I'll explain why that happens. These are the grey slags that we found sort of halfway up the hill. And these are weathered black slags. Looking on an electron microscope, the lead silicate slags, those splashes on stones that I've showed before, really a featureless glass. It's just lead silicate, nothing special. These bits in it are just bits of sandstone, bits of silica. The grey slags are barytes, the grey material there, held together by lead oxide or lead sulfate, but basically by lead compounds. And as I said, there's about 30% of lead in it. And then finally, the black slags with no lead in them whatsoever, typified by this electron micrograph here, where you've got a mixture of sort of calcium, barium, iron, silicates, mixed silicates with no lead. Basically, the calcium has displaced the lead out of the slags, but we do find that we get great black crystals of dicalcium silicate. Now, this was interesting because this stuff melts at 1500 to 2000, depending on whose data you look at. And you couldn't get above that. You couldn't get to that temperature in a bale or even in many coke blast furnaces. It's grown out of the melt. And it seems to be fairly typical of these black slags. And that's the reason why the slags are dull. If the slags are bright and brittle, then all they contain is this glass here of mixed silicates. As soon as they get the crystals in them, they start to go dull, and the more crystals, the duller they get, and the tougher they get as well. So you can tell by the tough when you strike them with a hammer. This one here is basically the same as that. You've got the dicalcium silicate, but you've got another mineral coming out here, which is calcium fluoride or fluorspar, and that comes out of these fern-like crystals as well. So we've got a problem. This is the site with the pollution scar, Google Earth. The pollution scar there's the wall, and somewhere around here is the smelting area. Didn't mean to do that. Down here at Morehouse Gill, completely different sort of slags. Here, the slags have got loads and loads of lead in them. Down here, we've got black slags, no lead in them. Loads and loads of charcoal. This area here is one big mass of charcoal. That wall has been built across some of the smelting area. There are stones in there that have obviously been in the smelting, have been used in the wall. And this looks like, as I say, a secondary smelting site. It looks as if, going back to the Bishop of Durham's smelting, this was where the primary smelt was carried out by using wood, possibly at a different time frame. And this rather sheltered location is where they had a furnace, probably driven by, powered by a bellows, hand-powered or foot blast. If we look at Fremington Edge, you remember one of the early slides I showed, I had 4 bales on Fremington Edge. The signs of lead, splashed lead on stones all over this area here. So it's almost certainly the area where those 4 bales were. But it's all been taken away. And what we see there is what has been left. There are documentary accounts that during the 1700s, a lot of the slag from Fremington Edge was taken to Marrick smelting mill, where they recovered lead from it. But we found further down, we found 3 sites. And this one here had charcoal with it. And we were able to do an excavation of that, again, funded by Northern Mines. We actually employed a professional archaeologist to make sure we didn't get into trouble and all that sort of thing. And he was very helpful and produced a very professional report for us. But we called in a lot of favors as well. So Rob Vernon, friend of mine, he's got a bit of a practice in geophysics. He did a flux gate radiometer survey of the site. You notice while we're looking at this picture, there is a flat area here, which is the area that we thought was possibly the scene of activity of the bale smelting. There's a steep bank and a wall on top. And this is my grandson looking at the results as they came off. The results of that were the difficulty with lead slags is that they're not like iron slags, so they don't have a magnetic signature. So they're very, very difficult to interpret. I can't really understand, but you can see from this that this is an area, there's slight rise here, and it's not easy to see, but there was slag apparent at the surface here. There was a bare, distressed patch up here, and there's a wet area here where there could well have been a stream running somewhere down here. On top of the wall, there seemed to be some anomalies in this area here. And when we excavated, we just took the grass off, the top grass up there. This was carpeted throughout with slag. And down here as well. So there was slag all the way here, here, and here. And underneath that slag was a very, very fine black layer. And we have since assumed, after some of the work we've done, that layer was the fact they just dumped the slag on the grass, and the black layer is what happened to the medieval turf when it decayed. It's not an indication that there's been any smelting or anything like that up here. The wall has been built over that, and lead spattered stones have actually been incorporated into the wall. One of the good things about this is that we did cover some of the area that was beyond the area of interest, so we got some idea of what an unaffected area looks like. So what did it look like? Well, there's a picture of me digging just to show I did a bit once. There's the wall at the back. That's an area where a bit of the grass has been taken away. And this is the main area of interest. There is, where this excavation is taking place, there is a huge charcoal deposit. It's not the remains of a fire. It's obviously been brought in to carry out smelting. So this is, to all intents and purposes, looks like a secondary smelting site where they've used charcoal smelting to get, as I say, lead out of other people's slags. The charcoal we identified sent it's 12 pieces away to Durham University for identification. All turns out, apart from one piece, to be hazel, which probably indicates that it's from a coppice woodland, or at least a managed woodland. It's not just natural wood that's been taken to make charcoal for smelting. The area where most of the smelting took place was covered in broken slag and this granular soily-like material, which is, after the dig we realized the importance of it, but it was very localized. It was in the area we thought the smelting had taken place, and when we removed all of that, we eventually got basically a collection of stones, and as we half expected, it would have all been destroyed so that people could get the last vestiges of the lead out. This was the only area where we found any lead. Some of the stones have lead spattered on them. Well, going back, one of the guys said, I don't think this is a smelting site at all, because we'd expect to see burnt clay on the floor. So we took that very seriously. We took some of the soil from the huge amount of soil actually and made these clay plugs out of it, took them up to various temperatures and then weathered them. We first of all soaked them in water, and the ones that had gone up to 100 degrees or 200 degrees collapsed immediately as soon as they got the water on them. I presume that's the one, and that's the 200, which is a little better. The ones that have gone up to 350 and 500, see, we're running out of time. They preserve reasonably well, but put them in the fridge, freeze them, wet them, freeze them. They do that a few times, and they collapse too. If the clay plugs were taken over about 950 or 1,000, then that would bake them hard enough to make them permanent. So to get permanent baked clay, you needed to get over 950. So we got into engineering techniques. This was a heat transfer textbook that I found, and it was basically an equation for how far do you bury a pipeline in Canada before it freezes up. That's what the example was derived for. So we used it to say, how far does this layer, so if the temperature of the fire at the surface is 1000, then the 950 temperature profile extends no further than 6 millimeters down. If it's 1040, which many of the slags melted at, the 950 profile is about 10 meters down, and this temperature, 1140, it goes down 19 millimeters. So nowhere does the baked clay get to an inch in depth. And that really explains, well, why we didn't find a baked clay layer. And it also, the weathering experiments seem to generate the collapsed type of baked clay that we found in that excavation. We're hoping that the study of bale sites will tell us a bit more about some of the mining that went on. This is the Copperthwaite vein, and it's such a complicated thing. I don't think it will tell us about that, but some of the nearer mines are little more than scratches on the surface. It's difficult to tell whether they're being mined seriously or whether these are prospecting grooves. We did a lot of, we have done quite a few carbon-14 dating, and we've put them in order. The names of the sites are there, but the thing that we really look for is the calibrated radiocarbon date. Surprise, surprise, that 1 in 8 there we found at 990, one at Ivy Scarl, actually it's at Haw Bank above Wensleydale, 1040, pre-conquest. One in Cumberland, this is in the Kelbeck Fells. We get 3 dates, and I'll explain why you get 3 days. It's when they do the measured radiocarbon date, you just get 1 date, but then I'll explain why you can end up with 2 or 3 dates. And then finally, some of these Carver here, 1420, that's a secondary smelting site using charcoal, much later. So you can see we're covering quite an area of history. And Lawrence Barker, he did one of the other sites at Carver, and we did 1420. He got more or less the same date there for the neighbouring site. Morehouse Gill, which is a secondary smelting, bit of a surprise. It was relatively early, is that 1265 to 1290, and the ones on the dig all turned out more or less 1420 or thereabouts. Again, typical of the secondary smelting sites. The trouble with radiocarbon dating is, I don't know if we have time to really go into it, but the calibration, it assumes, the first assumption is that the ratio of carbon-14 in the atmosphere is constantly being renewed, and when wood or whatever takes it in, that more or less freezes the carbon-14 to 12 ratio at the time when the tree was chopped down. The carbon-14 then, which is radioactive, starts to decay, and so you measure basically the depleted carbon-14. It assumes that the carbon-14 is constantly being renewed, it's always at the same concentration, and that the carbon-12, the normal non-radioactive carbon, is also at the same concentration throughout time. And apparently it's not, because very often you get things like volcano eruptions, and industrial processes where a lot of carbon, old carbon, is released into the atmosphere. So this mucks up the ratio. So what they do is they can accurately date known samples of tree using dendrochronology, tree ring dating. They basically drill various tree rings and radiocarbon date those and use that as the calibration, and that's why you get this curve. And in the middle of the medieval period, you get this horrible kink. And so when you get an experimental date like 580 years before present, that's before 1950, and extrapolate that through the calibration curve, you end up with 3 dates. And that's why we end up with 3 dates, and there's very little you can do about that. Finally, this is the oldest site of the lot, which was pre-conquest, about 900 and something. Ian Spenceley there, who showed us the site. We've now found probably about 4 other sites around this area, probably some of them medieval. And one of the things that we're trying to do is to survey this area here. There are the bale sites there. There's some here which aren't on the map. And try and strip away using the history. For example, we know these big shaft hills here are 19th century. We've got maps going back to the main period of mining in this area, which is the 1760s, when these hushes were dug out. We've got the remains of dams, which are quite easy to trace. One of them, I think, which is it? I think it's that one there, has actually got a sluice gate on it. And we can trace the leats that have come from those dams, and you can see that goes downhill that way, and it also goes downhill that way. So these look like prospecting leads. They've been used to cut through to find out where the ore is, and they've been cut through, so they predate the hushes, the big hushes here. Around, you get odd around here and here, we get local dressing floors where ores have been dressed. And this is Jinglepot's Gill in Apedale. So finally, that is where we hope one of the directions we can go is to learn a little bit more about the mining. It would be great to actually find where the Anglo-Saxons have mined lead, but as you see from that, most of this we can account for from historical mining in the 1760s and 19th century. It's a subject which has shown a lot of interest by the local inhabitants. We're digging around, and some of the local inhabitants turned up and carried out an intelligent discussion with us. The final plea, when I'm just going to finish, is if you visit these sites, can you please not take samples? There's not much there in the first place, and they're the only evidence that any medieval smelting has taken place. We've taken quite a lot of samples, and those are now in the National Slag Collection at Ironbridge. And if you wanted to look at them, use them, you would. The slag collection is run by the Historical Metallurgy Society. They have a website, and they would give you access to those slag samples, and they're in conjunction with slags from all over the world that British archaeologists have collected. So thanks very much for listening to me.
Thank you, Richard. Thank you. We have a question from Mike Smith, who asks, what was lead used for in this period, and was the lead mined in the Dales used locally or exported? And if so, what sort of quantities were being mined in this period?
well, the period goes from 1100 to
Yeah.
1400 also. By modern standards, not very much.
Yeah.
If we go back to the heyday of lead mining in the Dales, you're talking about big mines producing, the whole Dales output might have been 5,000 tons a year. Where I worked, and it wasn't a lead smelter, we produced that amount in 6 months. In a modern smelter, they used to reckon it had to be 60,000 tons a year to make it profitable. These guys were probably doing 10, 12, 10 tons or something like that a year at the most, maybe less than that, some years not even that. So, it's easy to see why some of those very low melting slags, they were lucky if they got a 100 weight out of it.
Yeah.
What was it used for? Well, the obvious use is the monastic lead. Fortunately, we have records for that. Used for roofs of ecclesiastical buildings, abbeys. Some of it was sent to Clairvaux in Normandy. I think that's in Normandy, for the roof there. Some of the Bishop of Durham's lead was sent to the Vicar of Darlington for use on his church roof. It would have been used for water pipes, and then it would also have been used for things like loom weights and stuff like that. So the big uses would have been for roofing and for water pipes and plumbing.
Right. Is there any evidence that there was smelting in the Malham area in medieval times, particularly with the Fountains Abbey connection?
You'd think they ought to be, and we searched it, and we've had various people who've taken us to places where they think they've been smelting, and they're not smelting sites, so we haven't found any. Yeah. Most of the Malham mines that you can see, and there's quite a lot there on Malham Moor and overlooking Kilnsea, of scratchings in the surface. They go down about 3 or 4 feet, that's as much, and then they run into water and so and they've all been traced to about 1700s, mid 1700s.
Okay, yeah. Has anybody else got any questions? If they want to put their hands up, just sort of do a quick run of. No more questions.
Love to find some smelting site. It's the other reason why you don't find them at Malham is that well, 2 reasons. One is, and it's the same at Grassington. There ought to have been some early smelting going on there, but there's the underlying geology is all limestone, which tends to fracture, it tends to fissure, and so they tried to avoid smelting on limestone. Most of the areas in Swaledale, even on limestone areas, they'd find a patch of sandstone and smelt on that, because they've got the sequence, the Yordale series sequence of rocks, and they were able to find bits of sandstone and smelt on that, and that was much more impermeable than the limestone. The limestone would fracture, form quicklime, and even if they did that, the traces would disappear. And then, of course, the lime would react with the acid products from the smelting, make a nice neutral fertilizer, and so you get grass growing over it.
Yeah.
So even if it's there, you can't see it.
It's gone. Right.
It's gone. Yeah.
Okay, so has anybody else got any? Mike, you'll have to unmute yourself. Mike Slater.
Yes, I wonder whether the word bale, bowl is connected with later mining. Bolling near Bradford and Baildon itself is covered with small coal pits. I wonder whether that word has changed its meaning in later centuries?
I don't know. I try to steer away from place names and things like that because I'm not an expert. There seems to be a distinct difference between once you get south of Doncaster, Derbyshire, and further south, it's all bowling, and further north, it's bales. So and there is this theory that it's a Danish or Norwegian word meaning a fire. And so it seems to have been used both for smelting in connection with that, but also it could be any other fire, like a beacon fire. And this seems to be the use in the West Pennines, on the pikes of the West Pennines. They're very unlikely places to actually, I mean, they're quite steep, so why would you carry lead ore up to the top of one of those to smelt it? You know, there are plenty of other places where you could do it much better, but would be a good place to have a beacon. And when you look at these place names, there's nothing there. But in Nidderdale, there does seem to be. Baildon, probably something to do with fire, I don't know. But it's funny, one of my old boss, when I was working in smelting, came from Bradford. And he went on Baildon Moor and drank some water, he said, when he was a lad. And it made him sick. But he went and took a sample of this water and passed hydrogen sulfide into it, and it went brown, which is a sign that there was lead there.
Plenty of slag
But
on
who
there
knows?
as well.
Anybody else got a question?
I can promise you, as an ex-Baildonian, that there is no trace of lead whatsoever on Baildon Moor, nor in Baildon. I'm afraid the geology there wouldn't support lead being there at all. Honest.
Right, that's that one then. Has anybody else got any questions? No? Well, if nobody else has got any, I just want to thank Richard so very much. You've introduced me, and I'm sure many others in the audience tonight, to a new subject. I found it fascinating, and it will be interesting to explore and see if I can find some of these bales which you've identified, and I'm hope I'm as good at discovering them as your wife obviously is. So if everybody would like to unmute themselves, or if not, Richard, you will be able to see everybody. If everybody would like to give a round of applause, and thank you very much for a very interesting talk. Thank you so much.